This video is to further illustrate the pigeonhole principle. In the previous video, we're able to establish the idea of pigeons and pigeonhole and provided its raw definition. Now, these are some examples where the pigeonhole principle is applicable, and it tells us a certain number of instances that it will happen. Say, for example, here, suppose you have 5 pairs of socks, which are colored blue, yellow, white, red, and black, to be placed in 4 drawers. Then it states here that at least one drawer will contain at least 2 pairs. Our pigeonhole here, and you have here your pigeonhole or pigeonholes, is actually the number of drawers. So say, for example, you have your drawer number 1. I'm just going to illustrate in this manner, number 3, and number 4. And then your pigeons, okay, your pigeons, in this case, pairs, sorry, or let me do it like this one here. So pigeons, or your pairs of socks, there are 5 of them, okay, 5 pairs, which will be placed in these 4 drawers. Take note, there is no indication as to whether all drawers must be filled, or only 1 or only 2 or 3 of these drawers. It's just that we'll be filling this 4 drawers with these 5 pairs of socks, and it tells us that there is at least 1 drawer, because if you're going to look into this one here, there are 4 drawers and 5. This connects to the idea that there are n plus 1 pigeons for n pigeonholes, and this supports the idea that if we're going to say, for example, you're going to place here the blue one or the blue pair, and you will have here the yellow, then you will place here the red pair, and let's say the white pair, okay, we still have the black pair of sock, and that would mean that regardless of where you will be placing this black, whether it's here or if we're going to place that here, this drawer will contain 2, at least one of those 4. That would mean this one here contains 2 pairs. Now, if another instance where you're going to place, okay, red and white here, and then you're going to place black here, that would mean 2 out of those 4 contains 2 pairs. Still follows the idea, at least 1 drawer, regardless of whether this drawer doesn't have any pair of sock. So this means that the number of pigeonholes is less than the number of pigeons. It will always happen that there is at least 1 of those pigeonholes, in this case drawers, will contain more than 1 pair of socks, or our pigeons in this case. Again, this is also true even if you're going to place all of these in this drawer. That would mean this will contain 5, this 0, 0, 0. Still, at least 1 drawer will contain at least 2 pairs. But generally, if all cases will have to put things into order, stating that we will be placing 1 for each first, definitely, as mentioned earlier, white, the black one, 1, 1, 1, 1, will make one of these 2 drawers, or 4 drawers rather, at least containing at least 2 pairs. Okay. Now, another example or illustration for the pigeon principle is this also. There are 8 of you in a group, okay? So, for example, you have a group of friends, group of colleagues, or group are in a certain, say, for example, transportation vehicle. Then, at least, it states here, according to the pigeon principle, at least 2 people will share the same birthday weekday. We know that there are 7 weekdays from Monday, okay? Sorry for that. We'll have here another color. So from Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. We have here 7. These are your weekdays. And you will have here, these are your pigeonholes. Okay? And then at the same time, imagine that you are riding a vehicle. Okay? Imagine that you're riding a vehicle and there are 8 of you. Now, there are 8 individuals. That would mean, since we have here 7 weekdays. These are your pigeons. We have n plus 1 with your n equal to 7 here. Automatically, once you have 8 of you, once there are 8 of you in a certain group of friends, group of colleagues, or even in a vehicle, there is a guarantee that at least 2 of you share the same birthday. So, for example, person number 1, he was born on, or he or she was born on a Monday. Another is on a Wednesday, Sunday, Saturday, Thursday, Friday, and Tuesday. And then you, being the 8th person, if you're going to consider yourself as an 8th person, definitely your birthday will also fall in either of this. That supports the idea that at least 2 people, which may include you, in a certain group of 8, will share the same birthday or weekday. So this is again another illustration for the pigeonhole principle, because in the previous video we just used the idea of pigeons and pigeonholes in a certain area where they are resting, or they are what do you call this one, the area that they are staying. Now this time we have 2 more examples. One is on pairs of socks and 4 drawers, and then we have here 8 of you in a group and the birthday weekday. In the next videos, we'll be trying to compute this. Our target would be identification of this. Okay, so we will be targeting this one here. What number? Okay, what number? I mean, yeah, in that specific context, how many individuals will fit a certain circumstance, or what is the maximum number? Basically, this is the more emphasized target. What would be the maximum number of pairs of socks or number of people in a group where there is at least a certain group, or 2, or at least one. I mean, at least 1 or at least 2 in this case will have the same characteristic. We'll be using the pigeonhole principle into that and some computations as well. Thank you very much for watching.